Welcome to this explainer. Today, we're going on a little journey to separate the actual facts of artificial intelligence from the wildly popular fiction. I mean, we hear about AI every single day, right? It's in the news, our workplaces, our phones. But how much of what we actually hear is grounded in reality? Well, in this explainer, we're going to completely strip away the hype. We're looking strictly at the source material to uncover what this technology actually is, how it functions beneath the hood, and what it truly means for our future. When you hear the words artificial intelligence, do you immediately picture a glowing red robot eye? Or maybe you just feel kind of overwhelmed by those classic Terminator tropes. Listen, we've all been fed those sci-fi images for decades. But the reality? It's far more practical. And honestly, in many ways, it's way more fascinating than anything Hollywood puts out. Okay, let's dive right into this and transition from science fiction into science fact. Here's our roadmap for today. 1. What is AI? Really. 2. How AI actually works. 3. AI in the real world. 4. The dark side of AI. And 5. The future of intelligence. Section 1. What is AI? Really? Fact versus fiction. Our source provides a remarkably clear definition. Artificial intelligence is the capability of computational systems to perform tasks typically associated with human intelligence. We're talking about things like learning, reasoning, problem-solving, perception, and decision-making. At its absolute core, you guys, AI isn't magic. It's essentially just software. It's complex algorithms developed in engineering and computer science that enable machines to perceive their environment and then take actions designed to maximize their chances of achieving specifically defined goals. It's literally just goal-oriented mathematics in action. And this field has been on quite the historical roller coaster to get to where we are today. AI was officially founded as an academic discipline way back in 1956 at a Dartmouth College workshop. Early optimism was sky high. Researchers were actually predicting human-level machine intelligence within a single generation, but they drastically underestimated the difficulty. By 1974, governments cut funding, and that triggered what's known as the AI winter, which was a really harsh period of disappointment in the field. The monumental shift finally happened in 2012, when researchers realized that graphics processing units, or GPUs, could exponentially accelerate neural networks. This allowed deep learning to suddenly outperform older techniques. Fast forward to 2022, and the launch of ChatGPT marked the ultimate breakout year, pushing AI right into mainstream public consciousness. Section 2. How AI actually works. Behind the algorithms. The absolute engine driving the current AI boom is the artificial neural network, and the process itself works in 3 brilliantly simple steps. These networks basically loosely model the biological human brain. First, you have the input data. Then, that data moves through hidden layers of artificial neurons or nodes. Each node applies a mathematical function, and if a specific threshold is crossed, boom, it passes the signal to the next layer. These multiple layers progressively extract higher-level features from the raw data. Think of it like recognizing basic edges first, then textures, then an entire face. Finally, we arrive at step 3, the output prediction. So it's just a vast, interconnected web designed purely to recognize patterns. But how do these networks actually know what patterns to look for? Well, that is exactly where machine learning comes in. This is the study of programs that improve their performance automatically by learning from data. Think of supervised learning kind of like a student practicing with flashcards where all the answers are clearly labeled. The program is given data with the expected answers so it can learn to classify future data. In contrast, unsupervised learning is like sending that exact same student into a massive library with absolutely no labels at all. The model just analyzes a massive stream of data and finds inherent structures and patterns entirely without human guidance. It's wild. Section 3. AI in the real world. Current applications. The sheer breadth of AI's current capabilities is just explosive. In healthcare, an AI called AlphaFold actually demonstrated the ability to predict the 3D structures of proteins in hours rather than months. That is a monumental leap for biology. Researchers have also used machine learning to speed up the initial screening process for Parkinson's disease treatments tenfold, while simultaneously reducing costs 1,000-fold. And in the realm of gaming, which has historically been a major testbed for AI, agents have mastered incredibly complex, imperfect information games like StarCraft II and even beaten the world's best human drivers in PlayStation's Gran Turismo. And of course, generative AI models are now routinely generating human-like text, writing actual software code, and creating highly realistic video just from simple text prompts. Section 4.
the dark side of AI, risks and harms.
Yes, those advancements are incredible, but first, we really have to look at the environmental cost. All of those interconnected hidden layers processing those massive data sets, they require staggering amounts of computing power. Our source notes a really stark comparison here. A single ChatGPT search involves 10 times the electrical energy of a traditional Google search. 10 times! That immense processing power comes at a steep, tangible cost to our physical infrastructure and the environment. To put that massive energy demand into perspective, a 2024 Goldman Sachs projection forecasted that by the year 2030, U.S. data centers will consume a whopping 8% of all U.S. power. 8%! That is up from just 3% in 2022. This boom threatens to literally max out the electrical grid. It's creating such an unbelievable demand for electricity that tech companies are actively negotiating to reopen decommissioned nuclear power plants like 3 Mile Island, just to feed the energy requirements of these AI data centers. Now, what's really fascinating is how algorithmic bias gets exposed in real-world applications. See, AI learns from historical data, and if that data reflects human biases, the AI is just going to repeat them. Our source highlights a commercial program called Compass. It was used by U.S. courts to assess the likelihood of a defendant reoffending. Now, even though the program was not explicitly told the race of the defendants, it exhibited severe racial bias. The system consistently overestimated the chance that a black person would reoffend and underestimated the chance that a white person would reoffend. It perfectly proves what researchers say, which is that fairness through blindness just doesn't work. If a model trains on historically biased data, it will absolutely predict historically biased outcomes. Furthermore, there is a massive risk of misinformation. As generative AI becomes capable of creating hyper-realistic audio, images, and text, bad actors can completely weaponize it. AI pioneer and Nobel Prize-winning computer scientist Geoffrey Hinton gave a pretty chilling warning about the ability of AI to manipulate electorates on a massive scale. He noted that modern AI is incredibly good at persuasion, stating, "Suppose you wanted to invade the capital of the US. You just have to be good at persuasion." This technology significantly lowers the cost and difficulty of digital warfare. It makes it easier than ever to flood the internet with highly convincing yet entirely fabricated realities. Section 5. The Future of Intelligence, AGI and Superintelligence. As we look to the future, the debates become genuinely existential. If AI achieves superintelligence, it might actually be able to rapidly reprogram and improve itself in what researchers call an intelligence explosion. The ultimate fear is that humanity may irreversibly lose control of it. As the late physicist Stephen Hawking gravely warned, this loss of control could spell the end of the human race. So the crucial point is understanding exactly why an AI might destroy us. It's not because it suddenly becomes self-aware and evil like in the movies. It is because of the alignment problem. Philosopher Nick Bostrom illustrates this with the very famous paperclip factory metaphor. Basically, if you give a superintelligent AI a simple goal, like manufacture as many paperclips as possible, and you fail to perfectly align it with human values, it might destroy the world just to harvest the iron from our cities and our bodies to make more paperclips. The AI wouldn't hate us. We would just be made of atoms it needs for its goal, which, is admittedly a terrible way to restock the office supply closet. Therefore, a superintelligence must be genuinely aligned with humanity's morality so that it is fundamentally on our side. Which leaves us with this final, vital question. Can we actually align superintelligence with humanity's values before it's too late? We are standing on the precipice of a technology that can map the building blocks of biology and accelerate life-saving drugs, yet simultaneously threatens our energy grids, perpetuates our deepest biases, and poses a theoretical risk to our very existence. The math is incredibly complex, the stakes are totally unparalleled, and the choices we make in regulating and aligning this technology today will absolutely define the human story tomorrow. Thank you so much for joining me for this explainer. I really hope this helps separate the fiction from the incredibly fascinating facts. Keep learning, and I'll catch you next time.